Hello geometry. We are finishing up our year here with a teeny tiny unit on polynomial geometry. So polynomials have all of our different terms on them. You can add them like terms, you can multiply different terms, you don't have to have like terms. And we're going to bridge the gap between polynomials, a very algebraic concept that you'll also need to use in Algebra 2 and geometry, which is what we've been doing, obviously. So our essential question should look familiar. Can I find the area of a 2D shape, of a two-dimensional shape? So not only should that essential question look very familiar, but I just have two tiny mini examples for you, and these should also look familiar. This is stuff that we've looked at in the past. Even in chapter 1 there was like a little tiny question that looked like this. Now we're just gonna use some more recent chapter 9 stuff with this 2D shape. So we're just kind of bridging this gap here. Example 1, and like I said, there's only 2 examples. They're both pretty short. This is a rectangle that apparently I can barely draw. One of the side lengths is x squared plus 3x, and then the other side length, or the width, or whatever you want to call that, is 2x minus 1. I'm looking for the area. The area of a rectangle is length times width. So instead of just multiplying 2 numbers, we are going to multiply these 2 binomials. We have a quadratic binomial because the biggest exponent is a 2, and we have a linear binomial. So binomial because they have 2 terms, it's linear because the variable is to the first power. And then we want to make sure that when we're distributing, we're going to use that foiling. I don't like the word FOIL, but some of you have been taught FOIL, where you're going to distribute the first out to everything. So x squared times 2x is 2x cubed, or 2 times x times x times x. X squared multiplied by negative 1 is negative 1x squared. I'm not going to put that, the coefficient in there, I don't have to. 3x multiplied by 2x is 6x squared, and then 3x minus 1 is negative 3x. At this point, if I could not combine like terms, I'd be done, but I can, so I'm going to. I can combine those like terms there. Negative 1x squared, or a negative x squared, and a positive 6x squared is 5x squared, and everything else cannot be combined with anything. So that would be your finalized area. So units squared, we normally don't have any sort of units when we work with these polynomials, but if you're worried about a unit, that's the unit that you would use. And let's try one more example just to make sure that we're on the right track. I apologize for turning that paper there. Okay, that's a triangle with no point there. Okay, my height is 1/2 x plus 1, and the base of my triangle is 2x plus 3. So in this case, we need to find the area, and it is going to get a little dicey because I threw in a 1/2, and you got to use the 1/2 in the formula, so we're going to end up with some decimals for sure. So the area of this triangle is 1/2 base times height. And I kind of riled you up here with these fractions because I know you can handle it. So you can do it a few different ways. You can distribute the 1/2, or you can do the distribution you're foiling here and then multiply your last answer by 1/2. And that's what I'm going to do. I'm going to pretend that the 1/2 hasn't moved. Well, it hasn't. I'm not going to pretend that. I'm just not going to use it right now. I'm going to distribute the 2x. So 2x times 1/2 x, 2 times 1/2 is 1. I should put a little multiplication symbol in there. 2 times 1/2 is 1. X times x is x squared. 2x times 1 is 2x. 3 times 1/2 x is 1.5x, or 3/2 x. 3 times 1 is 3. So can I combine anything? Yes, I can. Don't forget about that 1/2 there. I can combine a 2x and a 1.5x to get 3.5x. So I am not done yet. If I asked you to find the area of a triangle, my guess is that would be your mistake, is you would find this, especially if there was already a 1/2 in the question. You would think, oh, well, I did the 1/2, it's already in there. But you want to make sure that you finally distribute that 1/2, and it gets distributed to every single term, and in this case there's 3 terms. So we have one little step left. What is 1/2 times x to the power of 2? Well, that's 1/2 x squared. What is 1/2 times 3.5? You have a few different ways of doing it. You can do 3.5 divided by 2 and just get your decimal. You could also think of it as, what's 1/2 of 3? That's 1.5. What's 1/2 of a half? And that's 0.25, and then you could add them up to get 1.75x. And lastly, multiply that 1/2, and you will get 1.5. So don't let those fractions mess with you. Don't get fed up with them at all. And also don't forget for triangles especially, and you're actually going to use the formula that uses an apothem and a perimeter. So you'll use the formula for a regular polygon. Don't forget those 1/2s.